Dear students, let us start with estimation of roofs. As I told you before, in the unit 1 we are concentrating mainly on the roofs. You have 3 kinds of roofs, RCC sloping roof and Mangalore tile roof, and also you have the GI sheet roofing and AC sheet roofing with MS supports. So, RCC sloping roof we will start with first. So, what you are supposed to find out in RCC sloping roof? So, RCC, as I said before, it has 2 important ingredients. One is concrete, the other one is steel. So, we are supposed to calculate the volume of concrete and we are supposed to calculate the mass of steel in RCC. So, you have done the RCC slab before, which was flat, but now we are concentrating on RCC sloping roof. So, for this I have taken a small problem which consists of a single room which measures 3 meter by 5 meter, just to make you understand how to calculate the quantities for sloping roof. So, our topic today is RCC sloping roof. Okay. So, as I told you, we will start with a small problem which consists of small single roomed building. I am just drawing a single room with a wall thickness. So, we will take a 23 centimeter thick wall. So, there is a door here. Okay. I will take a small veranda here. Okay. So, I will just take I am drawing the roof here. So, our ridge comes at the center, ridge of the double sided roof it is. And we are just taking the eaves projection. So, room measures 3 meter by 5 meter. This eaves projection is 0.6 meter, and this we can take 1.2 meter in wide. Okay. These are the 2 treads of 0.3 centimeter, sorry 0.3 meter, 0.3 meter. Okay. So, this is the single room building with a simple roof, that is the ridge at the center, and you have the eave projection on both the sides. If I just draw the roof here, if I just draw the roof, I will just show you the 3-dimensional view of the roof. So, you have the wall here, you have the wall, okay, and the roof is like this. So, we are supposed to calculate the quantity of RCC in the roof. So, how do we calculate? The method of calculating I will explain now. What is the method of how do we calculate the quantity of materials which have been utilized in this roof? So, the procedure is, what we are doing is we are constructing a right angled triangle here. Okay. So, the height of the roof is, I will show you the section also, because you have to know the height of the roof. If I just draw it, elevation, so what I will take is, up till here height is 2 meters and from here to here it is 1 meter, and we have taken the eaves projection as 0.6 meter. Okay, these are the details. So, let us just remove this plan. You have understood the plan, I suppose. So, as I have told you, the triangular face which is formed here. Okay. So, this is a triangular face you have. So, your this one wall is here, your wall is here. So, what I will do is, I will try to form the right angle triangle here. So, this here we know the distance from here to here, it is 1.5 meter, sorry 1.5 plus your 0.23 thickness, it will be 1.73. So, up till here it is 1.73 and this distance is 0.6 meter. Okay. This here we have taken as 1 meter, it is only up till here, we do not know this distance. Got it? So, your wall is ending here, that is 1.5 plus 0.23, so that is 1.73 and your eaves projection is 0.6. Eaves projection is 0.6. So, 1.73 plus 0.6 is this horizontal distance, we know that, but we do not know this distance. So, we will try to apply the Pythagoras theorem here to find out the sloping length. We want the sloping length here, we want to find out the sloping length. So, how do we do it? So, what we can do is, we know this and we know this projection. Okay. So, we will just find out the ratio of it. So, 1.73 is to 0.6 is equal to 1 is to x. So, what I have done is, this is 1.73, you have the 0.6 eaves projection. Same way we have the distance 1 meter, we have here 1 meter. So, up till here we are taking the 1 meter. So, we have 1 meter is this distance, how much is this distance? So, by the method of ratios, what we will do is 1.73 divided by 0.6, since it is a ratio, this is equal to 1 divided by x. Okay. So, I will just take this to the numerator. 1.73x is equal to 0.6. So, x is equal to 0.6 divided by 1.73, that will be equal to, you have to use the calculator. So, 0.6 divided by 1.73 is equal to 0.34 meters, that is 34 centimeter. So, we find out this distance, which is 0.34 meter. So, this is totally 1.34 meter, this is 1.73 plus 0.6, then we can find out this slope length by applying the Pythagoras theorem. So, how will you apply the Pythagoras theorem? I will just show you. So, this distance is 1.3. So, this is your right angled triangle. So, we have find out this whole distance, it is 1.34 meter. Okay. This is 1.73 plus 0.6 will be 1.73 plus 0.6 will be 2.33. So, this is 2.33. So, how much will be this? So, according to Pythagoras theorem, this square hypotenuse, this is called as hypotenuse. So, I will just name this as A, B, C. So, according to Pythagoras theorem, AC square is equal to, okay, AB square plus BC square. So, AB is 1.34 square plus BC is 2.33 square. So, AC will be a root of 1.34 square plus 2.33 square. So, we will again use the calculator. So, 1.34 into 1.34 is equal to 1.79 plus 2.33 into 2.33 is equal to 7.22 root of 7.22. So, this will come around, that is equal to 2.68 meters. So, this will be 2.68. So, we got this distance, we have got this distance as 2.68. So, after we get this distance, it is very easy to calculate the area of the roofing or the quantity of concrete in the roof. So, according to the, how do you find the area of roofing? We have got the sloping length here, this multiplied by this will give you the area of this rectangle. This is a rectangle, since we have got the sloping length, this is 2.68, even this is 2.68. Okay. The room was measuring 3 by 5, the room measurement was 3 by 5. So, your room was 3 by 5. So, this distance is 3.46, this will be 5.46. Okay. So, we want this distance we wanted, which is 5.46 here. Okay. So, the area of the rectangle will be, so area of the roofing will be, area of roofing is equal to 2.68 into 5.46, that is equal to, again we have to use the calculator. So, 2.68 into you have 5.46 is equal to 14.67 square meter. Area of the RCC is sloping one side, this is one side 14.67. So, since it is a double sided roof, you have one rectangle here, the other rectangle is on the other side. So, you have two areas. So, when I just put the columns for the calculation, I will show you. This is serial number, item of work, number, length, breadth, depth, and you have the quantity. Okay. So, you have serial number, item of work, you have number, length, breadth, depth and quantity. So, I am just calculating for RCC roof. Okay. You have two such rectangles, so I will write 2. Your length into breadth you have got it as 14.67 and thickness of the roof is 0.15. So, this way you are calculating for the RCC roof. So, this is 14.67, you are taking into 2, okay. Then you are multiplying it by 0.15, that is equal to 4.4 cubic meter is your volume of concrete in the RCC roof. Hope you have understood this method. We will continue further with the with the reinforcement calculation in the next class.